Can you guys hear me or not? I mean, I'm not sure. I hope you guys can. Can someone give some feedback? Thank you very much, Nadiha. Right. We're still in the midst of chapter 3, salts and chloralkali industries. Last week, we have gone through the process of producing caustic soda using 3 different electrolysis cells. I hope you still remember it. The first one is actually known as Mercury Cell. Second one, Diaphragm Cell. Third one, Membrane Cell. Okay, probably just to test you before we continue our lesson today. I'll call names and then maybe you can tell a bit about each individual cell. Maybe check. Okay, Faris Azhar. Faris Azhar, you there?
Yes, Doctor.
Okay, Faris.
Yes.
Can you tell a little bit about Mercury Cell? What you understand about Mercury Cell? What would be the advantages and disadvantages?
From my understanding, the Mercury Cell produce a little bit around 50% of sodium hydroxide
Okay.
with low salt content.
Okay. What would be
So,
the requirements for Mercury Cell?
so the requirement for the Mercury Cell is the cathode should have a flowing of mercury lah.
So what would be the cathode in this case?
So in this case, I'm quite can't remember, but let me see. The cathode is the titan. No. The graphite is, or the titanium is the anode one. So for the cathode should be mercury lah.
Yeah, mercury. Yeah. So the requirement for Mercury Cell, the cathode is mercury, and then for the anode, the electrode is basically apa tu? Titanium or graphite.
Graphite.
Right. So what would be the product at anode?
So the product for the anode is, for the cathode, for the anode is hydrogen gas.
Hydrogen gas. Any other thing that forms apart from
Sodium hydroxide.
sodium hydroxide? Okay.
Yeah.
All right. Okay. So anything that you want to tell? I mean, more about the Mercury Cell?
Just the disadvantages that you asked me is the loss of mercury to environment. So that's mean it's harmful lah for environmental product.
Okay. All right. So thank you very much, Faris. Very good answer. Okay. And then probably we can have next one. Let me check. Who's the lucky one? Second one maybe Nerisha. Nerisha Peruma. Nerisha, are you there? Nerisha? Nerisha 1, Nerisha 2, Nerisha 3. No, Nerisha not replying. Okay. No, Nadia Nazuha. No, Nadia, are you there? No, Nadia 1. No, Nadia 2. No, Nadia 3. Senyap. I don't know. Okay, maybe I can ask another one. No, Atika. Atika.
Yes, Doctor.
Okay.
Okay.
Jika kena jawab lah, saya panggil. Okay. Right.
Okay.
So how about diaphragm cell? Can you tell a little bit what you can understand about the production of caustic soda from diaphragm cell? What would be the advantages and disadvantages?
Okay. Then diaphragm cell contain a diaphragm to separate the anode from the cathode, and then graphite as anode and cast iron as a cathode.
Okay. How
So
about the product?
the product,
Product at anode and product at cathode.
product at anode because chloride and also at cathode have two, which is hydrogen and also sodium hydroxide.
Right. Okay.
Right.
The cathode.
Cathode have two. One hydrogen gas and also sodium hydroxide. Then for the advantages, first one can run on dilute. Then
Dilute what? What do you mean can run
on
on
impure brine.
brine? Okay.
Yeah,
Okay.
20%.
Okay.
And then can produce 12 sodium hydroxide.
12%. Sodium
12%.
hydroxide. Okay.
Doktor nak tanya, yang advantages kan, yang satu slide tu dia tulis 11 persen, satu lagi 12%. So boleh tulis either one or 12%.
You can actually write it as because there's no specific, but the value is around that. You can write 11 to 12%. So it's okay. Okay.
Okay.
Any other things?
Then disadvantages, it consumes a lot of energy for evaporation.
Okay.
Then
And what do we need evaporation?
Because to dilute the brine solution.
To dilute?
Evaporation because we
It's
need
already
to
forming in a
because we
dilute.
need to evaporate brine.
Actually, we want to concentrate. We want to concentrate the final product because the amount of sodium hydroxide produced is quite diluted. So in order to increase the purity or whatsoever, then we have to undergo evaporation. Okay?
Okay.
Other things you want to tell?
No.
No, that's it. How about the diaphragm replacement?
Diaphragm?
Replacement. So this is actually part of the disadvantages as well because in for the maintenance you need to replace the diaphragm time to time. Okay, all right. So thank you very much, Atika, and maybe the last one before we resume our lesson. Okay, Yap Ki Yuan. Yap Ki Yuan, are you there? Can't hear you.
Yes, doctor.
Okay. Oh, very good. Okay. So, what about membrane cell? Can you tell something about membrane cell? What can you explain or discuss?
About the advantages and the disadvantages? Or
Yeah, I mean like advantages and disadvantages.
the advantages for this is...
Excuse me, I'm barely hear you. I don't know, maybe because of I'm not wearing any mic, I mean earphone, but can you speak louder a bit so that your friend can hear you?
Okay. For this membrane cell, it can use to extrude the OH and chloride ions from anode chamber. So it can make the product far lower than in salt compared to the diaphragm cell. And the second is it required only 1 liter water to be evaporated, so can produce a large amount of the 50% of sodium hydroxide.
Okay, okay, never mind. Yeah, Kiva, I think I'm hardly hear you. Maybe I can ask another one to continue with that. Who's here? Platform. Okay, Chong Shu En. Chong Shu En, are you around?
Yes, doctor.
Oh, very clear. Okay. Can you explain a bit about membrane cell?
The membrane cell, the anode is carbon or graphite electrode, and then it will produce the chlorine gas. And for cathode is iron electrode, and the product is hydrogen gas and sodium hydroxide.
Okay. Okay.
And then for the advantage, the sodium hydroxide produced is have high concentration, and it require lesser energy for evaporation.
Okay.
And then it has the semi-permeable membrane, which made up of polymer or naphthalene.
Okay. Right.
Yeah.
Any other things you want to add on?
No.
Okay. All right. Actually, by principle, there's no difference much. I mean, there's not much difference between diaphragm cell and membrane cell. It's only the separator. One is actually using a porous membrane like Nafion. Another one is using a composite, which is asbestos. Another thing is that the yield. So you have like diaphragm cell around 10 to 12 for membrane cell is slightly higher than diaphragm cell. This actually part of the reason why less amount of energy is required for evaporation. Okay, right. So I think maybe we have gone through brand purification process. Okay, as I said earlier, for the unit operation and chemical conversion that you need to consider in salt and chloralkali, of course, the brine purification, electrolysis, evaporation, salt separation, final evaporation, finishing, and special purification. Right. Basically, for brine purification, part of it, we call it as purification by means of using filtration aid, okay? Or you can actually treat the materials by using chemicals. So part of it, the process is known as Solvay process. Later on, you will understand more details about Solvay process for the production of soda ash, okay? Calcium, iron, and magnesium compounds normally plug the diaphragm. So the precipitation with sodium hydroxide is commonly used to remove them, which means in this case, if you want to remove out calcium, iron, and magnesium, especially calcium, you will see that there's a lot of calcium in brine solution, which normally comes from where? Anyone knows? Actually, the calcium coming from marine life like shells and cockles and whatsoever, because the shell is made from calcium mostly, okay, and then it can leach out, goes to the sea. Even corals also, dead corals contains a very high amount of calcium. Okay, iron probably some trace amount slightly, and magnesium. So when you treat it with sodium hydroxide, what happens is that the sodium hydroxide can react and it will form another salt product, like for example, calcium hydroxide, um, ferrous hydroxide, or magnesium hydroxide. All these are actually forming in the form of, insoluble precipitate. Then you can easily remove it out. Additional treatment with phosphate is required for membrane cell. This is actually true because phosphates normally can jeopardize or can actually block the membrane film especially. Sulfate can be removed by barium chloride, and brine is normally preheated with other streams to reduce energy requirement. So the last point, okay, over here, what does it mean is basically when you, slightly distill, we call it as heating or distill, okay? Distillation. Okay, what happens is that the brine solution will be more concentrated. And when you have a slightly high concentrated brine, then during the process, the conversion into caustic soda will be higher as well. Another consideration is electrolysis, okay? Especially the type of voltage applied. So this is actually the common requirement for voltage, okay, for electrolysis of brine solution, 3 to 4.5. And sometimes the cells that is used can be monopolar or bipolar. So what does it mean by monopolar? So cell is connected parallel and low voltage is applied to each cell. Okay, so these are examples of monopolar electrolysis cell. You see that it's connected parallel, the cell is connected parallel. And then you can also have bipolar, which the cells are connected in series and high voltage is normally applied. Okay, so the different monopolar, okay, cell connection is parallel, low voltage. Then for bipolar, the connection is actually in series and high voltage will be applied. Evaporation of caustic soda and salt separation. Around 11% of sodium hydroxide is produced from diaphragm cell. 35% from membrane cell are concentrated to 50% in multiple effect of nickel tube evaporators. So I believe I have explained slightly that when you have the solution, okay, a mixture of probably 11 to 30% of sodium hydroxide, this normally will be pumped, okay, and then it will goes into a heater. Okay, into a heater, arrow pointing inwards, and then what you can observe is that it goes into a nozzle. So you have a nozzle, and this nozzle is actually to increase pressure, it will be sprayed. So that is why I think later on you will see that your sodium hydroxide will form like in form of flakes, what, and the concentration can be slightly higher. Okay, salt will crystallize and recycle, concentrated to 73%, reduce shipping costs, but greatly increases the shipping and unloading problem. The high melting points of concentrated materials makes steam heated lines and steam heating of tank car necessary. The melting point for 50% of caustic soda is normally around 12 degrees C, and for 73% it's around 65 degrees Celsius, right? Membrane cell produce more concentrated caustic than diaphragm cell, less evaporation or treatment needed, especially for membrane cell. And then mercury cell produce around 50% solution, so no evaporation is needed. So this is part of the advantages of mercury cell that you have come out earlier on. The final evaporation, the cold and settled 50% caustic may be concentrated in the single effect evaporation to 70 to 75 sodium hydroxide using steam at 500 to 600 kilopascal. Okay, and the strong caustic must be handled in stream trace pipes to prevent solidification. It is run to finished pot, and another method is that the treating 50% of caustic solution with ammonia. This is also another thing to increase final evaporation. What happened basically when you treat 50% of caustic soda with ammonia, because both is actually strong alkaline, strong base, it can actually increase the exothermic process, and you will see, I mean, the removal of water can be increased as well, right? And the down-term heater evaporators normally used for the removal of water, and product is normally pumped by a constant pressure that discharge the molten materials into thin steel drum or into flake machine. Troublesome, normally impurities in 50% of caustic soda are the presence of iron, sodium chloride unreacted, sodium chloride, and also sodium chloride. So this sodium chloride is basically the I think part of the parasitic products produced during causticization process. Iron will be removed by treating caustic with 1% of calcium carbonate and filtration. Sodium chloride and sodium chloride may be removed using ammonia, aqueous ammonia. To further reduce salt concentration for some users, caustic is then cooled to 20 degrees C as shown in the following diagram. I'm not sure whether you can see it, barely. You can expand it a bit, right? And this is actually the side product or the byproduct. The byproduct from electrolysis of brine. So you have chlorine gas and also hydrogen gas. The dried chlorine is compressed, okay, to 200 or 500 kilopascal. This is actually in a low pressure, normally using a rotary compressor. A larger capacities and pressure, centrifugal and non-lubricated reciprocal compressor will be used. The heat of compression is removed and gas will be condensed. Liquid chlorine is stored in some cylinders, small cylinders, and hydrogen used in making another compound. So like for example, if you react chloride with hydrogen, then you can also produce hydrochloric acid. This part of the I think process that you will learn later on, chapter 6 or chapter 7. Okay, hydrogenation of fatty acids. Okay, of course, hydrogen is important for hydrogenation process, and finally for the production of ammonia from Haber process, where you react nitrogen with hydrogen gas. Right, video animation, probably you can watch the YouTube link, and I guess maybe later on once we have done with soda ash, probably if we still have time, we can watch the video. Okay. So today we are going to continue with another types of salts chloralkali product, which is known as soda ash. The soda ash is a layman term, but in the scientific or in the chemistry term, we call it as sodium carbonate. Okay, so sodium carbonate, the features basically it is an odorless, hygroscopic, it can absorb water, it doesn't have any smell, and alkaline in nature. where you can find people use sodium carbonate? I mean, where can you find sodium carbonate in daily use? Anyone knows? Anyone can give example? Siapa bagi example? Belanja coki-coki. Awanis, can you hear me? Not around? Okay, basically you can find soda ash or sodium carbonate in baking soda, in detergent, and many things. Okay, so chemically, sodium carbonate thermally decompose at around 1000 degrees Celsius, quite high, because normally for inorganic materials, like sodium carbonate, it will degrade at a higher temperature, not just, I think, lower than few hundreds only, normally 1000 over. Okay, so the thermal degradation of sodium carbonate, you will see that when you heat sodium carbonate, it can form sodium oxide, okay, plus with carbon dioxide. And the consumption of sodium carbonate will be lethal, will be deadly if 4 grams per kilo for rats and around 15 grams per kilo for human. Okay. The uses of soda ash, you will see a lot in the glass industry. Probably in chapter 5, we will learn about ceramics, and you will see the production of glass. Part of the raw materials it used soda ash as the component. Another thing is soda ash is also used for water softening agent. Okay, it is also used in the baking soda manufacturing. Okay, paper making, and in power generation to remove sulfur dioxide from flue gas. Okay, right. So if you notice, I mean, borax. Borax is widely known product for soda ash. In some people, especially in Europe or in the US, they use borax when they wash their clothes. So they just add like probably 1 cup or 2 cups of borax in the washing machine before they add the detergent. The reason is actually to clean, to ensure that the clothes washed in the washing machine will be clean. All right. There's a 2 manufacturing process for soda ash. This is important for you guys to remember. Only 2. The first one is known as Blanc. Okay, Blanc is actually the, I think, French name lah. So Blanc, for those who didn't know, it actually means white lah. Putih. Le Blanc, the black, the white process. This is actually the name of a person lah. Okay, and we have another one which is known as Solvay process. Solvay is also the name of a person. Okay. Later on, we will see what will be the advantages and disadvantages of these 2 processes. The first one is actually known as the Blanc process, okay, established in 1791, invented by a French industrialist or chemist known as Nicolas Leblanc. Okay, Nicolas orang putih, the white. In 1791, the salt cake. Ini bukan cake yang you makan tu. Salt cake is actually the hardened salt crystals. Okay. The salt cake is basically broken and pulverized. Pulverized means that it is crushed or grind, mixed with coke, not drinking coke. Yang ni coke is actually carbonate. And limestone, okay, and discharged into black ash, a rotary furnace consisting of refractory lined steel shell. Okay, the mass is heated by hot combustion gases entering at one end and leaving at the others. The molten gray mass, thus formed known as black ash, is separated from the calcium sludge and then crushed and leached with water in absence of air in a series of iron tanks, right? So you will see that over here, this is the unit operation or the flow diagrams of the Blanc process. So basically, you have like a furnace, okay, and salts, salts and sulfuric acid, NaCl, okay, sulfuric acid, H2SO4, okay, will be added into the furnace. This is actually the equation for process one. Okay. So 2 moles of sodium chloride reacted with sulfuric acid to produce a so-called sodium sulfate. Okay, so the sodium sulfate is basically the salt cake that we are talking about. Okay, so this is actually Na2SO4, right? So in the second process over here, okay, you'll see that coal or carbon will be added. Okay, this actually will form sodium sulfide, and then the sodium sulfide will be react with limestone or calcium carbonate, okay, to form, okay, the soda ash, sodium carbonate. Okay, right. So you can see this is actually the process, and part of it, the process one, you have a discharge of acid, hydrochloric acid over here. Okay, you have a discharge of carbon dioxide, okay, at one end, and then another one, you have a discharge of cadmium sulfide, sorry, calcium sulfide, not cadmium, calcium sulfide. So this is actually a problematic things. So I put like a warning over here. Okay, the reason why, okay, calcium sulfide is toxic. So when you have a huge production of solid calcium sulfide, then this will be a problem, like how you want to dispose it. Okay, so that is why for the Blanc process, it has certain disadvantages. The first one is actually everything will form in solid phase. Okay, you have a solid phase product. Amount of energy is quite high because over here you use furnace. Okay, you see furnace, and the amount of energy needed is quite high. And finally, you have the production of calcium sulfide, which is actually hazardous to the environment. Any questions so far? Anything you want to ask? Right. We are moving on to the next process. This process is known as Solvay process. Solvay process invented by industrials Ernst Solvay in 1861. Okay, this process is basically an improvement of the existing Leblanc process. Okay, in this process, continuous process using limestone, ammonia, and sodium chloride to produce sodium carbonate. Okay, so you'll see over here that you are treating the raw material is still the same. You use sodium chloride, limestone is also there, but here it actually use a strong alkaline, which is ammonia. Okay, the Solvay process, also referred as the ammonia soda process, okay, is the major industrial process for the production of soda ash. This is actually the only process that I think people in industry concentrates on for the production of soda ash because it's more environmental friendly, and I think actually the byproduct that you produce, it can be used for other purpose. Okay? The ingredients for this process are readily available and inexpensive because limestone you can easily get it. This one you can easily get it from brine. Okay, ammonia can also be produced. Okay, like for example, brine and also limestone. Basically, this is the process. You have brine solution, okay, reacted with ammonia into a tank, then this will be called as ammoniated brine solution. Okay, if it goes into a carbonating towers, okay, so what will happen next is that the CO2 will be I think introduced. But how actually you can produce CO2 is actually by reacting lime, okay, limestone, okay, maybe with some reaction. Of course, over here you will do a heating process. Okay, you will heat it because eventually what happened during heating or calcination, okay, CaCO3, okay, will be converted into CaO plus CO2, right? So this actually needed, okay, if it goes into the carbonating towers, it will be heated, and then what happened is it will produce a product. Okay, so the product that you will produce is basically calcium. Okay, sorry, the product that you will use later on will be filtered, and then the residue, okay, over here is basically ammonium chloride. Okay, ammonium chloride will be later on used for the ammonia recovery. The product that you produce over here is basically sodium hydrogen carbonate or sodium bicarbonate. Okay, right. So this one, the calcium oxide can easily react with moisture or water to produce calcium hydroxide. So calcium hydroxide, when you react it with ammonium chloride, okay, it can actually produce calcium chloride, okay, plus with ammonia, H3, then plus with maybe water, H2. So this can be recycled back. You can use it, okay. And this one as the byproduct, the waste, okay, water can easily be used later on. And from sodium hydrogen carbonate to get in soda ash or sodium carbonate, you can actually heat it, okay, at around 300 degrees Celsius. And what happens is that when you heat it, okay, it will form sodium carbonate, okay, plus with water. Okay, right? So the byproduct of calcium carbonate can be used in food additive, can also be used as an electrolyte and also dehydrating agent. So that's why normally when you react any chemical process, you will use calcium chloride as part of the process for hydration. You want to dehydration, right? You want to dehydrate, remove of water, right? Okay, so for the manufacturing process of Solvay, okay, basically you will require brine preparation, okay, and ammonia absorption, precipitation of bicarbonate, filtration of bicarbonate, calcination of bicarbonate, and finally recovery of ammonia. So this is actually the the process, a one by one process that I mentioned earlier. So first one, actually what happened is that you are producing ammonium carbonate, right? So this ammonium carbonate, okay, you react it with CO2. Okay, this CO2 is actually coming from calcium carbonate. heating. Okay. So when you heat it, you produce carbon dioxide plus with CaO. Okay. Right. And water. So then it will produce the so-called ammonium carbonate. So when you react ammonium carbonate with especially water and carbon dioxide in excess, this one in excess, what actually it forms is basically it will form ammonium bicarbonate or hydrogen carbonate. So this will be react, and later on what it will form is it will form sodium hydrogen carbonate. Okay. Right. So the byproduct over here that you will get is the ammonium chloride. So ammonium chloride will be react with this one. It will convert it into CaOH2. Okay. So when you react these two together, it will actually form ammonia NH3 plus with CaCl2 plus with water. Okay. Right. So this is actually the reaction that forms in the this one is occurs in the Solvay tower, number 1. Okay, and then for the lime kiln, so kiln is actually like a column, a heating column. This is where reaction 2 occurs. And then you also have calcination process that occur in calciner. So calciner actually converts sodium hydrogen carbonate into sodium carbonate. Okay, so this actually for 3. Yeah. And then finally, this process, the conversion of ammonium chloride, okay, ammonium chloride into ammonia is ammonia recovery process. 4. If you look over here, you will see that, okay, process number 1 is basically occurs here. Okay, and then this actually process number 2 in lime kiln. Okay, and then for the calciner, the process is actually undergo at when here, and then for the ammonia recovery also occurs over here. So this, I mean, equation, I mean the chemical reaction during the ammoniated brine solution, the production of calcium oxide and calcium hydroxide and whatsoever, including ammonia recovery, you need to remember it. Okay, so this actually will justify the solver reaction process. So of course, for both process, Solvay and Blanc, you need to remember what will be the flow diagram, of course, okay, and then what will be the process involved, chemical reaction, including the advantages and disadvantages. Of course, for this one, you don't have much disadvantages. Okay, the only thing is for Solvay process, part of the disadvantages is still it needs higher amount of energy. Okay, so reason because you have lime clean and also you need calciner. So these two process is actually high temperature process. Okay, so that's why you need high amount of energy. Advantages, of course, the byproduct can be used. Okay, for other purpose, and then the other thing will be the raw material. Raw materials, okay, is easily found. Okay, like for example, brine and also ammonia, brine and lime. Okay, right? Any questions so far? Before we go to the last slide, okay. So the last slide is actually where the purification of ammonia. Right? Oops. Purification of ammonia normally use an adsorber. It's like a filter. Okay, this actually will give a counter current flow. Okay, it cool the products to remove heat from the solution, and also slightly less pressure. Made from cast iron, okay, and at the exit you will have around such concentration or such amount of sodium chloride, ammonia, and also carbon dioxide. And finally, you have carbonators. This is actually where the calcination process occurs. Normally installed in 6 to 9 in numbers with 20 to 30 meters height. The exhaust or the furnace. The exothermic process occurs at around 60 degrees C. It reduces solubility of sodium hydrogen carbonate. Use cooler at the bottom temperature around 30 degrees C. And finally, in the carbonators, it's also used a vacuum rotary filter at the bottom. So basically, we have a few videos that just to show the Solvay process. Any questions so far? You want to ask? No, probably we can like watch the video. We'll try to select this. Okay, so probably while waiting for the videos, okay, some homework for you guys to do, actually to discuss, okay, the difference between the Blanc process and Solvay process. Okay, you can make it into infographic. Okay, you can use. I mean, you can make it like a poster or something, visual graphics to explain the difference between the Blanc process and also Solvay. I set the deadline probably till Thursday. Okay, what is it? Please. Okay. Any questions so far? Ada soalan? Ada ke tak ada? Right. This one is no longer available. Let me copy the other one. And for your information, few recordings have been published in YouTube last week. And those who have missed the lecture, you can follow it
Solvay process.
Okay, let me share the screen. Right, so can you guys see this? Sure. If you can see it, please give a response.
Yes, Doctor.
Okay, very good.
Solvay process was devised by the Belgian chemical engineer Ernest Solvay in 1864. Nearly all sodium carbonate is manufactured by this process. Sodium carbonate is commercially prepared by the Solvay process, which makes use of the fact that sodium bicarbonate is less soluble in cold water than sodium chloride. The raw materials required for this process are sodium chloride, limestone, and ammonia gas. Shown here is a schematic diagram of the plant used in Solvay process. Click on each part to know more about them.
Okay, so this is basically the
Observe closely the direction of movement of the arrows.
flow diagram of the Solvay process.
The flow chart for the Solvay process is depicted here for easy understanding of the process.
More or less, it is the reaction that we have seen in for Solvay process. All right. So, okay, I think probably that's the end of our lecture today. We have concluded chapter 3 on salts and chloralkali. The most important thing that you need to remember for chapter 3 is the production of
Good grammar and spelling are important, but if you want to write essays that inspire.
Okay, sorry. Part of the things that you need to remember in chapter 3 is the production of caustic soda from these 3 electrolysis cells, and then finally for the production of soda ash from the Blanc and also Solvay process. Okay, so remember I've give you a homework to do a graphical poster or graphical chart or whatsoever graphical poster, okay, to explain the differences between the Blanc process and also Solvay process. And yes, I will set the deadline till Thursday. So please do so. Tomorrow we will have a quiz, and tomorrow we will start a new chapter in extractive metallurgy. So before I end, any last question from you guys? Yes, no, 1, 2, 3. Okay, so if no, I will adjourn the class. Thank you very much for your kind attention. Hopefully to see you tomorrow. So thank you very much. Assalamualaikum and goodbye, everyone.